Okay. This question deals with combinations and permutations, so we'll read through it, pick out the important stuff, and we'll go through both the A and B part. So a small transit bus has 8 window seats, 12 aisle seats. 10 passengers board the bus. How many arrangements of all window seats being occupied are there? And then there's 2 different options, if order doesn't matter and if the order does matter. So let's highlight what's important here. We have 8 window seats, 12 aisle seats, 10 passengers, and then the final question says all window seats are occupied. Okay, I'm going to kind of draw out a scenario here. We'll use blue for window seats. So there are a total of 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then there were 12 aisle seats. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. So we know there are a total of 12 aisle seats here. And then we have 10 people. So let's kind of fill up this here. In the first one, they say order does not matter. Okay, well, all the window seats get filled. Essentially, we have a person in each of them. Let's kind of just check it off. 1, 2, 3, 4, 5, 6, 7, 8. That leaves us with 2 people. These 2 people are now being shoveled around these 12 aisle seats. So the question is, how many different ways can we choose 2 people out of the total of 12 options we have there? So we take out our calculator. We want to know how many ways can we choose 2 out of 12, and there are 66 different ways to essentially choose that. The reason we don't have to do any of the other counting because the order doesn't matter, and we know these all have to be filled, and because it doesn't matter if this is Bob and this is Dave, it doesn't matter where they're sitting, whether at the aisle seats or they're in here, it doesn't make a difference. So this is the only calculation we have to do for the first one. Order matters is a very different story. Okay, when order matters, okay, let's kind of duplicate this and put it down here. Copy. Put this down here. Yay, okay. When order matters, what ends up happening is if this is Dave and this is Bob, well, when they change seats, Bob's here and Dave's here, that's an entire different situation. Or Dave's here and Bob's there, different situation. Or Bob's one of these 2 people, different situation, which was not the case above. So now when we're setting this up, what we need to do is, first of all, there are 10 people, right? We have 10 people to choose from. We need to occupy the first 8 seats. So the first 8 seats come into play here. We need to figure out how many ways can we choose 8 people out of 10. But it's not choosing, sorry, this is a permutation instead. So we have 10p8 for the window seats. That's how we're choosing the window seats, is 10p8. Okay? And then for our second situation, we then again have 2 people. But this time, where they sit and what order they sit in is very important. So again, it's a permutation, and we're multiplying by how many ways can we choose 12p2. Okay, and this deals with, actually I'll do this in red so that we can see the visual relationship. This deals with all of the aisle seats. Okay, aisle seats. So we need to make these 2 calculations. So let's get our permutation here. No, I want a function. Permutation, okay. We're looking for 10, choose 8 as our first number, or sorry, 10p8. I keep saying C because we did so many combinations. And it's that very large number, 1814400. So I already forgot. 181. 814400. So that is 1,814,400 different ways times our aisle seats, and that is 2 or 12p2, 132. And just notice that This 132, 12p2, very different number from 12c2. Very much a very much bigger number there is. So now we multiply these two values together to find out. So this is that type of situation where we have to multiply the two of them because we had two different things to calculate. So we have the first number multiplied by the second number. And this number is huge. What the heck is it? 200. Okay, let me write it underneath. 239 million. Keep losing my calculator. 500,800. 500,800. So very big difference between the combination of 66 and the permutation of almost 240 million different options.